Okay, so on Friday we talked about angle bisectors and what that meant in a triangle. Today we're going to talk about perpendicular bisectors. So do y'all remember what perpendicular means? What does that mean?
Two lines that touch once but don't touch again.
Kind of. It means that when they do touch once, what do they form when they touch? A right angle. So perpendicular actually means 90 degrees, or it forms a right angle. Okay, so that's what we're going to be looking at today. Now, on Friday we talked about what equidistant meant, and that's just an equal distance. Okay? So, for example, if we're looking at this picture, X would be equidistant from A and B. So I could label that showing that using these tick marks. Okay? Now, the definition of a perpendicular bisector. Now, what does bisector mean again? Cuts in half. Okay? So a segment that passes through the midpoint of a side of a triangle is what a perpendicular bisector is. It is perpendicular to that side of the triangle. So looking at this picture right here, the perpendicular bisector is going to be XY because it passes through the midpoint, which is Y, and it is perpendicular to the side AB. So midpoint means, what does that mean about if we go through the midpoint Y? What does that mean about AY and YB? They're what? They're congruent, or they're equal, and they show you that with the tick marks. So if the perpendicular bisector goes through the midpoint, means that these two bottom pieces of the triangle are going to be congruent. So that's what the midpoint tells me. And then it also tells me that it's perpendicular to, which means it forms right angles. So they drew one of the right angles, but what does that mean about this right angle as well? Well, it means that this one is a right angle. So I would draw a right angle on both sides. Now, the theorem tells me that if a point is on the perpendicular bisector, like X, then it is equidistant from the end point of the segments. Okay? So, point is on perpendicular bisector means equidistant from the endpoints. So that's talking about these sides. X to A would be equal distance to X to B. Okay, and then the opposite applies. Converse just means the opposite. So it's saying, the converse is saying if this distance, X to A and X to B, are congruent, then this segment is a perpendicular bisector, and all of this applies. Okay? Are there questions about that? Okay. We also talked about the point of concurrency on Friday. The point of concurrency is just a point where all the lines intersect. 3 or more. Okay? Now, the circumcenter. So Friday we talked about the incenter. Today we're talking about the circumcenter of the triangle is the point of concurrency of the 3 perpendicular bisectors. So my bisectors, or my perpendicular bisectors in this figure, are the ones that form the right angles. So this is a perpendicular bisector, this is a perpendicular bisector, and this is a perpendicular bisector. So the very center of all of those is called the circumcenter. Now it tells me that the circumcenter of the triangle is equidistant from the vertices of the triangle. So what are the vertices in this triangle? Do y'all remember what vertices are? No? Okay, vertices are just the edges or like where the two sides meet. So A is a vertice, B is a vertice, and C is a vertice. So this tells me that the circumcenter, from the circumcenter to the vertices, are equidistant. So if I drew a line, because those lines are not right, from the vertice to the center in each of these, and I will highlight so we can see them a little better, then all of these lines that go from the vertice to the circumcenter are going to be equal. So I'll go ahead and put a tick mark there to signify that those are equal. So does this look very similar to the same picture that we had on Friday? It should, because we were looking at angle bisectors, which look very similar to these, and then the point from the in-center to the side, which looks like our perpendicular bisector. Okay, so let's try to apply these to some problems. So looking at number 1, it shows me that these two sides are congruent, and this is a 90-degree angle, so that means this is a 90-degree angle. Okay? And it also implies that if this is a perpendicular bisector, which it is, what does that mean about the length from X to W and Y to W? They're equal. Okay? So what is the distance from Y to W? 5. Okay, and number 2, it shows me that the distance from this point to the end point and this point to the end point, these are the same, and this line is perpendicular. So does that make it a perpendicular bisector? Yes, and so what does that mean about BD and DC then? They're equal. So what is the distance from B to D? 19.7. Okay, then in number 3, it shows me that these sides are equal, which means that this is perpendicular, which means what about PS and SQ? They're congruent, okay? And then it asked me for PQ. How would I find PQ? Okay, we can multiply 8 by 2, or we could just say, I know this is 8, so 8 plus 8 is 16. Okay? Questions on those 3? Okay, let's look at number 6. So number 6 says, given that P is a perpendicular bisector of XZ, so P right here, this line, is a perpendicular bisector of XZ. So that means this and this is congruent. It means both of these are 90. And what does that mean about X to Y and Z to Y? They're the same distance. Okay, so now that I've got that labeled, I'm going to plug in my information. So it tells me X to Y is 4n, and it tells me Y to Z is 14, and it wants me to solve for n. So what do I know about those two lengths? They're what? They're equal. So we would do 4n equals 14. We divide both sides by 4. And n equals 3.5. Okay, let's look at one more like that. So looking at 7, it tells me xy is equal to zy, and that wx, which is this length right here, is 6x minus 1, and then it tells me xz, which is this whole length right here, is 10x plus 16. Okay, so we have a whole length and then we have half of it. So what do you think we would do to solve for this? 2 times the part, which is 6x minus 1, equals the whole 10x plus 16. So from there we just take 2, we distribute. 2 times 6x gives us 12x. Minus 2 times 1 is 2 equals 10x plus 16. Okay, so from there we subtract 10x. That gives me 2x minus 2 equals 16. Then to get x by itself, we would have to add 2 to both sides, which would give me 2x equals 18. And finally, we would divide by 2, and x equals 9. Okay? It tells me to find ZW. So how would I find ZW? What would I plug it in for? Very good. So ZW is equal to XW, which was 6x minus 1. So we just take 9 and plug it in. So we do 6 times 9 minus 1, and ZW would equal 53. Okay, do I have questions so far? Okay. Alright, so for this one, it tells me that QS is a perpendicular bisector. So if QS is a perpendicular bisector, that means that these angles right here are going to be 90 degrees. It means that MS is going to be equal to SK, and it also means KM is congruent to QK. So that's everything that we talked about up there. Now we can start the problem. So it tells me that angle QSK. So if I start at Q, go to S, go to K, we're looking at this angle right here. It is 6x plus 18. Okay? And then it wants me to solve for x. So what could I set 6x plus 18 equal to? 90. Very good. We know that this angle is a right angle, so we would do 6x plus 18 equals 90. We would subtract 18 from both sides. That would give me 6x equals 72. And then we would divide both sides by 6, and x would equal 12. Okay, thoughts on that? Okay, now in number 9, it tells me that TP is a perpendicular bisector. So that means that these angles right here are 90, and the distance from S to T is the same from T to O. Now, why can we not say that from S to this line and from this line to R are congruent? Does anybody know? No? Okay, so in the first one, we could say that from M to Q and K to Q were congruent because this point Q landed on the perpendicular bisector. In this one, is there a point that lands on the perpendicular bisector that is between the two? No. So we cannot conclude that this distance is equal to this distance. We can only say that where the perpendicular bisector intersects is congruent. Okay? So that's the difference in those two, is that this point would actually have to be somewhere on this side. Okay? So it tells me that ST, which is this length right here, is 3x squared minus 3. And then it tells me SO, this entire length, is x squared plus 13x. So if I have a whole length and part of a length, what formula am I going to need to use? 2 times part equals whole. So we're going to do 2 times 3x squared minus 3 equals x squared plus 13x. Okay? So I'm going to take 2 and I'm going to multiply that out or distribute, and that's going to give me 6x squared minus 6 equals x squared plus 13x. Okay? So what are we going to need to do with all of our terms? Move them to one side. So we're going to take x squared and move it to the left-hand side by subtracting x squared from both sides. That's going to give me 5x squared. Now, if I move 13x over, does it have a like term? No. So it's just going to be minus 13x, and then I'm going to leave minus 6 the same. Okay? So we have 1, 2, 3 terms, which means we are going to factor by trinomial, but this is not shortcut because we have a 5 here. So do y'all remember how to do this? Very good. We're going to do 5, our first, times the last. 5 times negative 6 gives me a negative 30. And then I'm looking for a factor of that adds to give me a negative 13. Yes? Very good. Negative 15 and 2. So I'm going to take these numbers and I'm literally going to replace negative 13 with these numbers. Everything else I'm going to keep the same. So I'm going to bring down 5x squared. And then instead of writing minus 13x, we're going to put minus 15x plus 2x. And then I'm going to bring down my minus 6. Okay? So we can replace negative 13x with negative 15x plus 2 because if I added this back together, what is negative 15x plus 2? Negative 13x. So they're the same, so they can be replaced. From here, we have 1, 2, 3, 4 terms, and so to factor with 4 terms, we do what? We group. We're going to group our first 2, group our last 2. What is the GCF in this first parentheses? 5x, and that leaves me with x minus 3. What's the GCF in the second parentheses? 2, which leaves me with x minus 3. So I did it right because my parentheses match. And so I would write this as 5x plus 2 and x minus 3. Now, we know what this x equals. What would this x equal? 3. Now, this one's a little bit different. We would actually have to solve for 0. So, if we solve for 0, we would first subtract the 2 and then divide by 5. So that would be negative 2/5, right? Okay, questions about that? Okay, let's look at number 10. So for number 10, it tells me MY is a perpendicular bisector. So the first thing I want to do is label the triangle. Perpendicular means it forms right angles. So I'm going to draw my right angles. Bisector means it's splitting it in half. So NY is equal to YE. Then it asks me to solve for X. So I have this angle right here, which is 2X. Have this angle right here, which is 7X. And then I have this angle, which is 90. What could I do to solve for X? Yes. 2X plus 7X equals 90. That would work. Could we do 2X plus 7X plus 90 equals 180? Yes. Either way, that would work. So we would add 2X plus 7X, which gives me 9X equals 90. We would divide by 9, and X would equal 10. Okay? Let's talk about 12, 13, 14, and 15, just to make sure that we got those. Okay, so it tells me that DY, EY, and FY are perpendicular bisectors. So I'm going to highlight those so I can see them. DY, EY, and FY are all perpendicular bisectors. So let's label what that means. What does perpendicular mean? 90. So every time this hits, it's going to form a 90-degree angle. So I'm going to go ahead and draw my 90-degree angle. And then what does bisect mean? Cuts in half. So where this one hits, it makes AD and DB the same. Where this perpendicular bisector hits, it makes BE and EC the same. And where FY, that perpendicular bisector hits, it makes AF and FC the same. Okay? There's one last thing we've got to look at. What does that mean about the line going from the circumcenter to the vertices? What does that mean about AY, YB, and YC? They're equal. Because it's going from the circumcenter to the vertice. Okay? So we have labeled everything that is congruent. So looking at finding CF. CF is this length right here. What is it the same as? AF, which is 59.7. You just literally look at what you labeled. YC, what is it the same as? 63.9. YB. And then DB is the same as AD, which is 62.8. And AY is the same as YB, so 63.9.